class. It is going to be held at Unisim HQ, Block B. It's in Blackboard. It's LT 3.27. Okay, LT 3.27. Now the course will be such, the quiz will be such that there are going to be 10 MCQ. Out of the 10 MCQ, sorry, not 10, there are 20 MCQ. Yes, got a sample. This is a very long time ago. Oh, okay. So, but this is okay, this is a sample, very close to what we will be having. The quiz contains 10 multiple choice questions, 6 structured short questions. Okay, now out of the 10 multiple choice questions, there will be 6 on fluid mechanics and 4 on thermodynamics. Now, I have given you a series of review questions. If you recall, don't forget them. At our very first encounter, this is on Blackboard. Remember, we went through these questions. You all have them? Okay, please go through them carefully. Okay? Go through them carefully. There are 1 or 2 typos which, remember we did this question. The last question, there was some queries. Question 11. Can you see the diameter of the jet is 2.35 cm? And the answer is 23 meters per second, correct? But there is a typo on the diameter of the jet, 2.35 cm, not 4 cm. You look at the 2 answers, I think 1 or 2 of you pointed it out to me. There is an error here, because if you use 4 cm, you get actually 7.96, and there are no answers. I think 1 or 2 pointed it out. So when I went through, then I discovered the reason why I used it is quite interesting. Can you see this is 23 meters per second? And question is, this is 2.35 cm. So it's not the answer that is wrong, the stem the main stem is a typo. So please go through this review. This will give you a good idea what the quiz questions for fluid mechanics is going to be. There are going to be 6 questions. Then 4 will be thermo. Now, for the structured question, there are going to be 3 of fluid mechanics. 3 of fluid mechanics. Now, in the 3 of fluid mechanics, I would like you to go through the seminar where we had the tutorial seminar 2. Let me show you that. Okay, this is the seminar 2. The Lully and the energy equation. Okay, go through that. In particular, I'd like you to look carefully at this question on the water draining out of the tank. Here. We go through this example of the water draining out of the tank. Remember when we first started, I gave you an example. The very first time we met, remember you have this. The fluid mechanics readiness test, where you had to fill up all the details, and then after that, there was a question on water flowing through the tank, and then you were supposed to determine the height. Okay? Go through that question. That question and the water draining out of the tank. In other words, the question in the quiz that will be asked will be something like a water draining out of the tank, and you will have to determine the calculation. Okay? Whether there could be 1 hole, there could be 5 holes, but if you understand the concept, go through this example and the seminar 2 example. Okay? Then that is one question. The other question, which is very important, is the pitot tube. I emphasize a lot on the pitot tube. I'd like you to go through that again very carefully. The pitot tube is this example. Okay, this example question 12-32. how the Bernoulli equation simplifies and how you can substitute to get your answer. So study that. This is an important question. Okay? So we will ask a quiz question on the pitot tube. So one question will be on water draining out of the tank. That is Bernoulli's equation. Then the other one will be also pitot tube, which is also Bernoulli's equation. Then the third one will be a descriptive. What is cavitation, or what is the meaning of external flow or internal flow? Yeah, a descriptive sort of question. So go through the definition of internal flow, external flow. Remember you saw the video on the various kinds of flows, internal, external, laminar flow, turbulent flow, that kind of definition. Now, the rest, momentum, etc. is not up at all. Only seminar 1 and seminar 2. Now, kinematics. Remember, kinematics was taught very recently. All you need to know, remember the missing chapter which I printed for you. Okay, and I wrote out the definitions for streamlines, path lines, street line. What is the definition? This one is available in Blackboard. I put the whole chapter, but you don't have to go through the whole chapter. All you need to know is how to define what is a streamline, a path line, a street line, and a timeline. And then look at the pictures that define these different types of flow visualizations devices. Okay, so that covers the 3 questions of the quiz. They are short, structured questions. You're only given 1.5 hours, so it's not much of the length of the question. So study these in particular carefully. Okay? Any questions before I... There is no formulas given for fluid mechanics. Okay? So, allow me to borrow your markers. You need only 2 formulas in fluid mechanics. One is this famous one, A1 V1 equals A2 V2, where A is the area, A equals pi d squared over 4. Okay, this is called the continuity equation. So you will not be given this formula. In addition, you must know that Q in fluid mechanics, remember Q is volumetric flow rate. Is equal to V times A. The velocity times the area of the fluid. Okay, so this is expected out of you. And the next thing that you need to know is the Bernoulli equation along a streamline. So this is Bernoulli's equation. Along a streamline one to 2. So you are expected to be able to quote this, and you need this when you're doing the question on the draining of water from a tank. You have to start from the level, draw a streamline to the outer point. where the water leaves the particular tank. Then you must be able to say P1 and P2 in a water draining scenario is at atmospheric pressure. Then PV1 at the water level at the top is very small. And Z1 and Z2 are the difference in gravity, and then you can work out what is the velocity V2 leaving that particular container. Please go through that carefully. In the pitot tube also, you have the streamline. Look at the example carefully, see where the point 1 and the point 2 and how it is simplified. In the case of a pitot tube, Z1 and Z2 are the same because it's a horizontal tube. And how you can make use of the difference in the pressure to calculate the speed of the particular airflow. So go through that example. Okay, you need to know these two examples very well. Any questions before I let Mr. Loh take over? 3 questions for fluid mechanics, 2 for thermodynamics. Okay. Now, the other thing is, the day after your quiz, we will upload the lab manual. Now, the lab manual, unfortunately, is about 45 pages. Okay? So, what I have done is, at the end of the lab manual, is all the data collection. So, if you don't want to print out the whole lab manual, all you need to do is just print out the data collection section, which is about 5 or 6 pages. Then you can bring your laptop or you can bring your tablet and use the PDF file to read through and do the experiment. Saves you printing the whole manual. Okay? There are colored pictures in the manual describing the instruments, etc. So in your case, only you need to take down the data. I will also, with Mr. Loh, we will tell you how we are going to break you up after the quiz, how we are going to break you up into 2 groups to do the lab classes, but more about that later on. Okay? Yeah, I will stop here. Thank you. Okay, thank you. Yes. Sorry. I can't. Yes. That would be simple. You look at the second half of the multiple choice question, simple calculation. Okay. A typical example with the pipe diameter is 20 cm. The velocity is 5 meters per second. Then the pipe diameter, because it's a nozzle, becomes from 20, it becomes 5. Calculate the new velocity. So you know A1, B1 equals A2, B2. Calculate the area. Remember, not diameter. Area times the V1 equals smaller area times the V2. Substitute and get your answer. You are actually using the continuity equation. So yes, MCQ, there will be 1 or 2 simple calculations like that, then you choose the correct one. Yeah. No, 6 fluid, 4 thermo. 10. Sorry, short, 3 fluid, 2 thermo. 5. 5 for the 5, each one is worth 16 marks. So 5 times 16 is 18. The MCQ, each one is worth 2 marks. So 2 times 10 is 20. No penalty. You do, I would advise you to try. all the question. Even you get it wrong, you still get it wrong. Okay? Yes.
One question, when we apply the Bernoulli's equation, right, do we need to write down all the assumptions?
Yes, it would be good. In the quiz, we are not so particular, okay? But in the exam, Bernoulli question also will come out. Okay, in the exam, yes, you have to write all the assumptions. In the quiz, okay, it's good if you get into the idea of writing the assumptions. If you look at my solution, all my solutions